Hi students, welcome to Vidyanagar online classes. In our last class, we have discussed the first effect of electric current. What was that effect? Do you remember? Yes, we have discussed about heating effect of electric current. Now, in this class, we are going to discuss the second effect of electric current. That is magnetic effect of electric current. So, what we are going to discuss today? We are going to discuss magnetic effect of electric current. Okay? We will understand this magnetic effect of electric current with a simple activity. What you have to do? First of all, take a cardboard tray. Okay? Take a cardboard tray. And then wrap an electric wire around that cardboard tray. Okay? What you have to do? You have to wrap an electric wire around that cardboard tray. Now take one compass needle. You all know compass needle? Yes. Take one compass needle and place it inside the cardboard tray. Okay? What you have to do? You have to place a compass needle inside that cardboard tray. Compass needle is also a magnet. Okay? Place that compass needle inside the cardboard tray. Now connect the circuit as shown in the photo. You can clearly see that the switch is off here. That means the current is not flowing. After connecting the circuit as shown in the photo, what you have to do, you have to note down the direction of the compass needle. Okay? What you have to do, you have to note down the direction of the compass needle. After that, take one bar magnet. Okay? Take one bar magnet and move that bar magnet near the compass needle. Okay? When you move that bar magnet near the compass needle, you will observe that the compass needle gets deflected. The compass needle gets deflected. Now remove the bar magnet and switch on the current. Earlier the switch was off, now switch on the current. Even though you have removed the bar magnet, now also when you switch on the current, the compass needle gets deflected. Okay? When you switch on the current, the compass needle gets deflected. Now again switch off the current. When you switch off the current, the compass needle gets back to its original position. Okay? Now it is not deflected. So what can we say from here? We can clearly say from here, when a compass needle is brought near, when a bar magnet is brought near to the compass needle, or when an electric current flows through a wire, the compass needle gets deflected. Okay? When an electric current flows through a wire, or when a bar magnet is brought near to the compass needle gets deflected. So we can say from here that when an electric current flows through a wire, the wire behaves like a magnet. Okay, the wire behaves like a magnet, and this is known as magnetic effect of electric current. So what is magnetic effect of electric current? When an electric current flows through the wire behaves like a magnet. This is known as magnetic effect of electric current. Okay? It will become more clear to you with the help of this short video. Okay? Watch this short video carefully.
Let's do an experiment to know about the magnetic field of electric current. Take a used matchbox and remove the cardboard tray out from the matchbox. Wrap an electric wire around the cardboard tray a few times. Take a small compass needle and place the needle inside the cardboard tray. Connect the circuit as shown in the diagram. Note down the direction to which the compass points. The compass needle is also a magnet, having its ends pointing in both north and south direction. Take a bar magnet and move it near to the compass needle. Observe the compass needle carefully. When we move a bar magnet near the compass needle, the needle gets deflected. Remove the magnet and turn the switch to on position and Now note the direction of the compass needle. There is a deflection in the compass needle when the switch is in on position. The compass needle gets deflected due to the magnetic field induced by the current. Turn the switch to off position and note the direction of the compass needle. Now the compass needle comes back to the original position. Repeat the both experiments few times and observe the deflections. Relate the two experiments where the compass needle is deflected by a magnet and by a wire carrying electric current. When the magnet is brought near or when the current flows through the wire, the magnetic needle gets deflected. So, we can understand that the wire acts like a magnet when electric current is passed through it. This is called the magnetic effect of electric current.
And this magnetic effect of electric current was first noticed by a scientist named Hans Christian Ørsted. Who noticed it? Firstly, Hans Christian Ørsted. Okay. So now as you have understood the magnetic effect of electric current, we can say that electric current can also be used to make magnets. Electric current can also be used to make magnets. We can understand this with the help of simple activity. What you have to do, you have to take an iron nail. Okay, take an iron nail and wound an insulated wire around that iron nail in the form of coil. You have to wound an insulated wire around that iron nail in the form of coil. Then connect the free ends of the wire to the cell through switch. Okay, you have to connect the free ends of the wire to the cell through switch. And then place some pins near the ends of the iron nail. Okay, you have to place some pins near the end of the iron nail. And then switch on the current. As soon as you switch on the current, you will see that the iron nail attracts the small pins. The iron nail attracts the small pins and the pins will cling to the end of the iron nail. So, the coil in this activity acts like a magnet when electric current flows through it. And when electric current is switched off, the coil loses its magnetism. Such coils are called electromagnets. Okay, so what is electromagnet? A current carrying coil. A current carrying coil of an insulated wire wrapped around a piece of iron. Okay. What is electromagnet? A current carrying coil of an insulated wire wrapped around a piece of iron is called electromagnet. Understood? Electromagnet is used in many devices. Like it is used in large machines which are used to lift the cars. Okay? And then electromagnet is also used to separate the magnetic material from the junk. Okay? Then doctor also use electromagnets to separate out the magnetic materials that have accidentally fallen in our eyes. Okay. Now we are going to study about electric bell. Okay. This is the circuit of an electric bell. It consists of a gong. This is gong which produces sound. It also consists of the coils of wire which are wounded over the iron pieces which will act like electromagnets. And then there is one iron strip which is kept close to these electromagnets. And this iron strip is also in touch with the contact screw. And then there is one hammer. So this is the circuit of an electric bell. Now how does this electric bell rings? We will see here. So what happens? First of all, when the electric current flows through the circuit, these electromagnets will show magnetic properties. When electric current flows through the circuit, these electromagnets will show magnetic properties. And then these electromagnets will attract this iron strip. These electromagnets will attract the iron strip. And the iron strip move towards the electromagnets. When the iron strip move towards the electromagnets, the hammer also move towards the gong. And when the hammer strikes the gong, it produces sound. But at the same time, when the iron strip moves towards the electromagnets, the iron strip loses its contact with this contact screw. When it loses the contact with contact screw, the circuit breaks and the current stops flowing, and these coils will not act like electromagnets now, and this iron strip come back to its original position. When it comes back to its original position, it will again get in touch with this contact screw. When it gets touch with contact screw, the circuit again completed and the electric current again starts flowing. And when the electric current again starts flowing, these electromagnets will again show magnetic property, and this iron strip is again attracted towards the electromagnets. And when the iron strip moves towards the electromagnets, the hammer also moves towards the gong, and the hammer strikes the gong and the gong produces the sound. This process is repeated again and again, and this is how the electric bell rings. It will become more clear to you with the help of this video.
Most of the bells we see nowadays are electric bells. Here's a very simplistic diagram of an electric bell. This is the inner structure of the bell. Let me first tell you the names of the basic components. This is a push switch, which is nothing but the switch we press when we ring the bell. This is a coil of wire wound around an iron piece. There could be two coils of wire wound around an iron piece as well. Remember, we've just drawn a simplistic version of the actual circuit. So it will act as an electromagnet when the electric current flows through the circuit. This is a battery and this is a striker which strikes this gong. That's when we hear the sound. So we can see that this is a circuit that can be formed. It's not complete. Why is it not complete? Well, we haven't pressed the switch yet. When we push the button, the circuit gets completed and the current flows from the positive to the negative terminal. But when the current flows through the coil, it becomes an electromagnet. This electromagnet then attracts this soft iron towards it. And in the process, the striker strikes the gong and the sound is produced. But notice what happens when the striker hits the gong. As soon as the soft iron is shifted away from its original spot, the circuit breaks. It no longer connects this wire with the terminal of the battery. And when the circuit breaks, the current stops flowing. So this electromagnet gets demagnetized, after which the soft iron goes back to its start position. This process will continue until the switch is open again. As soon as we release the push button, the circuit breaks and the bell stops ringing. That's the basic idea of how an electric bell works.
So that's all in today's class. We will meet soon in the next class. Thank you.